3.
1, 2, 3.
Oh wait, you should be here. Let's count again. 1, 2, 3. You should be here, not in the jail.
Okay.
And that's mine. So I want 3 millions.
Okay.
Okay. 5. 1, 2, 3, 4, 5.
Oh wait, is it my country? I guess.
I think so.
Can I find it? What's his name? Okay. Yeah, I found it. Okay, it's 2 million.
Okay, 2 millions. Millions. Okay.
Oh!
Where did it go? Okay, I can't find it.
Yeah, okay. So miserable. I'm so miserable.
Okay.
I don't want to play. It's boring and everything just disappeared. Right? It's really boring.
Wait, I have an idea. Why don't we make an automated monopoly for our embedded systems project?
Oh, that's a great idea.
Okay.
Yes.
Okay, your turn.
Yours.
Cairo. Your
5 steps.
4, 5. Okay, now turn. 1, 3, 4. Okay.
You wanna bite?
Okay, I'll bite.
Okay. My turn. 5 steps. 3.
Do you wanna buy Abu Dhabi?
No, I don't wanna bite. Haha!
Jail. Jail. Ouch.
2, 3. Your turn.
It's my turn. Okay, can't get out of jail.
Okay. Haha! Money. Still my turn, no?
Uh-huh. Again. Okay.
Hello, we are Mariam and Sherien. We participated in the hardware part of this project, and Sherien will start explaining it to you now.
So, we have 16 cells. Each cell has 2 players. So for each player, we bought a decoder 4 to 16. Each decoder has 4 inputs. The inputs come from the Arduino. These 4 inputs for this first 4 inputs for the first decoder, and this second 4 inputs for the second decoder. The input, here we have the voltage for the decoder, 5 volt, and the same here. And we have two enabled inputs from the ground and the ground input here. Each decoder has an output, so each output enters the board to light the LEDs. So this is the first output. Let's just move there. The first output, and here the first output here for the player number 2. And for each cell, the same scenario. When we bought the decoder, it was active low, so it was active high, it was active low, so we had to make it active high, and that's what Mariam did. So please, Iman.
Hi. The way we changed the active low decoder to active high is that we made a common 5 volt node for each player. This common 5 volt node, here this is the 5 volt, this is the node for this board. We made the this node enters the positive pole of each LED, and the negative pole of the LEDs are connected to the output of the decoders. Why we did so? Because we wanted when the output of the decoder is low, the LED lights. So we made the 5 volt, so when the decoder outputs 0, it will make the potential difference through the LED positive, so the current will flow through the LED and it will light up. However, when the output is 1, it will negate the 5 volt and it will make the potential difference 0, so the LED will switch off. And that's exactly what we want. Moreover, we connected the LCD. The LCD is divided into 2 parts. This part, pins, are for the buttons, and these are the interface pins, which is responsible for the input characters and the electricity of the LCD. And that's it.
Hello, I will introduce you to the software part of the project. It's mainly divided into 3 main parts. The first one is the setup function, which initializes the game and all its variables by initializing the initial positions of each player and give him or an amount of money to start with. After that, it initializes every single cell of the 16 cells of the game, giving it its name, price, group, and rent. After that, there is the loop function, which has most of the logic of the code. It's mainly what it mainly does. It's checking for the turn of the player and checking who's the active player right now. After that, it waits until the player rolls a dice and acts upon that. By checking if the player is on a special cell, one of the corners, or one of the countries. After that, it checks if the country is owned by any of the players, and if it's owned by the opponent, the player should pay rent. This loop keeps on repeating over and over until the game is over. However, the setup function is executed only once when the code is first executed. And now I'll leave you with Nour to explain the third part of the software.
The third main part of our code is the helper functions that we use and that are called throughout the code. The first major helper function is the move function. It is responsible for the movement of the player. It takes the player that should move, the number of steps, as well as the delay that should occur on each step. And it loops on these steps, updating the position of the player and assigning each pin accordingly. The second, third, and fourth major function are pretty similar. They are to pay money, earn money, or transfer money. Where they loop on the amount that should be paid, earned, or transferred, and they update the balance accordingly. The other functions are exclusive to the LCD part. The LCD is divided into 3 parts. The first are 3 major parts. The first part is for the balance. The second is the middle of the LCD, and the third part is for the ownership of the current country that the player is on right now. So we have a method that will update the LCD balance part, which will set the cursor and clear whatever is in that part and updating accordingly for both players. Similarly, in the middle and the last part of the LCD, we pretty much do the same. We set the cursor again and clear, and then we set the appropriate value. Another method for the LCD is to take the input. We take the input as an analog input, and according to the voltage of that input, we know which button the user pressed, and we act accordingly upon that. The final helper method is to end the game. It's pretty simple. We clear whatever is in the LCD. We set the cursor and we write game over. We display which player is the winner, and we make the flag, the game over flag, true, in which it will stop the loop function from executing over and over again. And that's our code. Thank you.